This is Geometry, Chapter 6, Section 4, in which we will be studying rectangles. One of your favorite shapes of all time. Quite certain of it. Because rectangles are very nice. They have 4 right angles. Specifically, they are parallelograms that have 4 right angles. Now, since we just said a rectangle is a parallelogram, everything we've talked about back in 6.2 still applies. Opposite sides are still parallel. They're still congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. All of those things are true because it's still a parallelogram. It also has another special property besides having 4 right angles. The diagonals of a parallelogram are congruent. That's the really neat thing about parallelograms. Their diagonals are congruent. So they're going to throw us what looks like a curveball, but it's not that scary. They want us to find the length of PR if we know that TS is 120. And a lot of people freak out over this kind of problem because all you have is this one little side right here is 120. And you got to figure out this thing. Well, since it's a parallelogram, that means they bisect each other. So if this is 120 from S to T, then TQ is also 120, which makes QS 240. And since it's a rectangle, the diagonals are equal. So if QS is 240, then PR is also 240. People freak out over that because they don't think about what it means to have a bisecting diagonal. And if you remember, all your parallelogram properties are still valid. It makes the problem a lot simpler. Okay. Now the converse is also true. If the diagonals are congruent, if you have a parallelogram with the diagonals congruent, then you have a rectangle. Now notice there are 2 facts you need to know to make this theorem work. First off, you have to know what you're dealing with is a parallelogram. If it's not a parallelogram, this theorem goes out the window. Okay, it's possible to have diagonals be congruent and it not be a parallelogram to start with. So you can't just go by the lengths of the diagonals. You need to know you have a parallelogram first. Then, if you know it's a parallelogram, then you can figure out the lengths of the diagonals. So let's determine whether we have a rectangle based on the 4 vertices. Okay, remember, the first job you have is to decide if you have a parallelogram. Now, we have a lot of options in front of us. We could find out if the diagonals bisect each other. We could find out if opposite angles are congruent. We could find out if consecutive angles are supplementary. Those would be kind of a pain with this situation. We could find out if opposite sides are congruent. That would work. But the quickest way would be to look at the definition of it and try to find the slopes. If we know that we have 2 sets of equal slopes, then that means we have 2 sets of parallel lines, and that means we have a parallelogram. So let's find the slopes. The slope of j to k, y minus y over x minus x. reduces to -4. KL, -6 minus -3 over -8 minus 5 is 3/13 time you reduce it. Well, those two sure aren't parallel. L to M, -3 minus 5 over 5 minus 2 is -8/3. Well, that doesn't match anything. And M to J, 5 minus 2 over 2 minus -10 is 1/4. That doesn't match anything. Since it's not parallel to start with, it's not a parallelogram, so then it's also not a rectangle. Okay. Right away, I've been able to shoot the whole thing down because it's not even a parallelogram, so it can't be a special parallelogram. Supposing we had gotten congruent slopes here, or equal slopes, then the next thing you would do would be find the length of JL using the distance formula and the length of KM using the distance formula. If your lines were parallel and then those distances were equal, then you would be able to say it's a rectangle. But alas, in this case, we couldn't do that. Darn. So nice, short and sweet video. Fairly easy lesson because we like rectangles a lot already. If you had questions along the way, hopefully you jotted those down. Bring them in to ask, and we will see you in class.